Hi everyone, welcome back to this session. So in this session, we'll learn how to evaluate credit risk model. See, when we are talking about evaluating the probability of default model, there are certain metrics which are used in general by credit risk modeling team to understand how the model has performed. So let me first write what are those metrics. We have accuracy, precision. So okay, accuracy, precision, recall, F1 score. These are very important metrics which are used for understanding how the model has performed. Other than this, what do we use is AUC ROC curve, KS statistics, and population stability index. So in this video, what I'll teach you is accuracy, precision, recall, F1 score, AUC ROC curve. And if in case you want me to explain these two, just drop me a comment and I'll explain these two too. But let's understand accuracy, precision, recall, and F1 score in an easy format. So before going, okay, so let me draw one table which helps you understand this in an easier way. So let's say, just remember these two terms, positive and negative. Positive and negative. So positive means whatever we are trying to model, whatever we are trying to model. So in this case, what we are trying to model is whether the borrower has defaulted or not. So this is nothing but what we are trying to model. Okay. What we are trying to model. This is positive. Negative means not defaulted. That the borrower has not defaulted. Okay. Now, this is what I mean by positive and this is what I mean by negative. Now, there is this thing called a confusion matrix. There is this thing called a confusion matrix. Okay, this is nothing but a table. Okay, let me explain you. We have actual prediction. So we have, oh, okay, sorry, actual default, actual no default, predicted default, predicted no default. Okay, so now let me first write it true positive, true negative, false positive, false negative. Just don't worry, I'll explain these terminologies. Okay, but just remember this whole table is called what? It's called a confusion matrix, in which you have actual default, actual no default, default, predicted no default. And now and this, as I said, is what? True positive, false negative, true negative. But let's understand these terms. Okay, true positive. So always remember, the second term is what? Prediction. So true positive means what? That the model has predicted, positive. That the predicted predicted positive, which means what is positive? It is default. And true means what? True means what? True means it is correct. Actual also. So this part signifies your actual. Okay, this part, the first part is your actual, the second part is your prediction. Always remember, the first part is actually what happened, and second part is prediction. So when I say true positive, this is what is predicted, and actually is also true, which means whatever we have predicted is correct. So this means model has predicted positive, and actually also it is positive. Actually, it's positive. Actually, it's positive, which means that the borrower has defaulted. Okay. So basically what I'm trying to say is, always remember when I say true positive, okay, whenever I say true positive, the first term defines what has actually what has happened, and second term defines what is the prediction. So prediction is positive. Prediction is what? Positive. And when I say true, true basically means true means actual is also positive. Okay, true means actual is also positive. But let's say I write false. Let's say I write false positive. You know, I write false positive. So this is actual, and this is what? Your first term is actual, your second term is prediction. Always remember, your first term is what? Actual, what happened. Second term is what the model predicted. So the model predicted what? Positive. The model predicted positive, which means default. Now false. What does false mean? It is incorrect. False means what? It is incorrect. So basically, actually, there was no default. Actually, there was no default. Is this clear? Please tell me. Is this clear? So when I write, okay, so when I write true positive and false positive, what is the difference? So when I write true positive and false positive, what is the difference? The difference is in both the cases, what is the prediction? Prediction is positive, and positive means what? Default. Prediction is, in both the cases, prediction is that the borrower has default. True means actually the borrower has default. Actually, the borrower has default. False means the borrower, in actual, the borrower has not default. Please tell me, is this clear? Please tell me, is this clear? When I write true positive and false positive, so always remember this is what has happened in actual and this is your prediction. This is what has happened in actual and this is your prediction. So in both the cases, prediction is positive, which means positive means prediction is defaulted. But in this case, actually the borrower has defaulted. In this case, actually the borrower has not defaulted. Okay. Similarly, let me write the other two terms. False positive and false negative. False positive. First, let me write this. Okay. This has what actually has happened. This is what the prediction is. Okay. So this is what actually has happened. This is what the prediction is. Can you tell me what is the prediction? It is positive. What is positive means? Defaulted. And it says false, that it has not happened. So actually is, in actual, there is no default. In actual, there is no default. And when I write false negative, when I write false negative, so always remember this is first term means your actual, second term means true positive. Okay, so we have already covered true positive, false positive. We have already covered this. Sorry. Then it is true negative and false negative. Okay, so let me write this. Okay, let me erase this because we have already covered. Instead of this, let me write true negative and false negative. Sorry. Yeah. So we have true negative. Don't worry, you don't have to memorize. We are just trying to understand. You don't have to memorize. We are just trying to understand. So we have true negative and false negative. This is what actually has happened, and this is what the model has predicted. So what the model has predicted is negative, which means no default. Because in positive means, see, if you remember, positive is what? Default, negative is no default. Okay. And what is true? True means actually also there was no default. Okay. Is this clear? And then false negative means this is your actual, this is your predicted, that the model predicted negative, which means what is negative? No default. But it is false, which means in actual, there was a default. Is this clear? Is this clear? Please tell me. Is this clear? So let me write all the four terms. Okay, so let me go back to the table. True, positive. So true, positive. Always remember the second term is what? Prediction. So prediction is what? Positive. Positive is what? Default. And in true means this has actually happened. True means this has actually happened, which means if the prediction is default, actual is also default. Okay. False positive. False positive means what? False positive means what? In the prediction is positive, which means the prediction is default. And false means actually there was no default. Actually, so when we say true, when we say true, this is right. When we say false, this is wrong. Okay. So when the model says, okay, so this means the model is predicting what? Positive. Positive means default. The model is predicting default, but in reality, there is no default. False, negative. So in this case, the model is predicting negative. Negative means no default. Okay, the model is predicting negative, which is no default, and this is what it is saying is this is false, which means in actual there wasn't default. Okay, similarly here the model is predicting negative, which is no default. The model is predicting no default, and true means this is true, which means in reality, in actual there was also no default. Is this clear? Please tell me, is this clear? Okay, now let's jump to the matrix. Let's jump to the matrix part, where we'll cover what is accuracy, precision, recall, and F1 score. Okay, so what is accuracy? What is accuracy? It is the percentage of correct prediction. Okay, accuracy is what? It is the prediction of, it is the percentage of correct prediction, which means accuracy is equal to true positive plus true negative upon true positive plus true negative plus false positive plus false negative. This is the accuracy. Okay. So is this, first tell me, is this clear? So what does accuracy means here? Accuracy is nothing but all correct prediction, all correct prediction by all total prediction. All correct prediction. See, true positive, true negative means what? Whatever it has predicted is correct. Whatever is the model predicted is correct, right? So it is all the correct prediction by all total prediction, right? All total prediction. Is this clear? Please tell me. Please tell me, did you understand what is accuracy? It is true positive plus true negative divided by all the four terms. Please tell me, is this clear? Okay. So next, let's understand what is precision. Okay. So please tell me if it's not clear, I can repeat it. Okay. Sounds good. Okay. Next, let's see what is precision. See, precision is, let me write the formula first. Precision. It is true positive by true positive plus false positive. Okay. What does this mean? Okay. What does this mean? This basically means this, of all the people your model said, of all the people your model said will default. Okay. Of all the people your model said that the people will default, how many actually did? How many actually did? So if you see true positive plus false positive, and this in the numerator we have true positive. True positive means what? True positive means what? That the model predicted as positive, and in actual also it is positive, and positive means default. Okay. Okay, so one more thing is, lot of times interviewer will ask you, hey, can you define this in easier term? Or can you tell me what's the formula? So I'll tell you, how the way to remember the formulas. Okay, I'll tell you the way to remember, because I know this sometimes this can be, confusing of, oh, what to remember and how to remember. Don't worry, I'll tell you. But just let me know if anything is not clear, okay? In the chat section, please let me know. So then we have something called recall. We have something called recall. And if you ask me the formula, see recall, if you just look at the formula, it is true positive by true positive plus, if you see, false negative. So if you see these two formulas, what is actually changing is this part, this part. Okay, what is changing is this part. So true positive by true positive plus false negative. Now what this recall means, of all the people who actually defaulted, how many did model catch? Okay, so of all the people, of all the people, of all the people who actually defaulted, how much, how many did the model catch? Okay, tell me one thing. True positive and false negative. So what does this mean? That the model predicted positive and actually also it was positive. Here it means what? Model predicted negative, but actually it was positive. So what we are saying is, in this case, actually what happened? Actually there was a default. This is what actual and this is prediction, right? So how many model? So actually, actual is what? How many defaulted? How many defaults in actual? So what this mean? This term, what it means is, in actual, in actual, how many people defaulted? And true positive means what? How many it was able to capture? Well, right? Why? Because prediction is what? Positive, and true means in actual also it was positive, which means prediction was default and actual also was default. That's why I say that of all the people who actually defaulted, this the denominator is what? Of all the people who got defaulted, this is defaulted, and numerator is what? How many model catched? That the model, how many was your model able to catch? Similarly, here also in precision, let's write true positive and false positive. So tell me, in true positive, your prediction is what? Positive, but actually what happened was also positive because it is true. In this case, false positive. So prediction is what? Positive, but what actually happened is reverse. So we'll have negative. So what are we seeing is commonality is positive. Commonality is what? Positive, which means, okay, so positive, which means it actually predicted the right, okay, it predicted the right thing. And in this case, what false positive means what? Of all the people your model said will default, this means your model said what? It will default, but did it do? So what we are trying to capture is here in the denominator, when the model said it's positive, which means default. Okay. So here if you see, positive is common, right? Which means your model is saying it's positive, but then we are checking how much was actually positive. Okay, is this clear? Please tell me, is this clear? So now the question is how to remember this formula, right? How to remember this formula. So I'll say easy thing to do is, see, accuracy is what? Always remember accuracy. You can just remember like this, just remember the formula: true positive plus true negative by all. Okay, by all. So just remember accuracy, because this is not confusing at all. But when it comes to precision and recall, it becomes confusing. So how to remember both the formulas? So see, precision is what? Total positive by total positive plus false positive. Okay, so this is what is your precision: total positive by total positive plus false positive. Okay, always remember how to do this. Okay, so it's basically total positive by this whole thing. Okay, and similarly, what is your recall? It is again total positive, but then it is the denominator will be this part, which is total positive plus false negative. This is the way to remember the formula. See, if you can visualize it, or if if you can mug up. But this is the way you have to defend the answer in your interviews. And also, this is very important for even credit risk. Like, how do you evaluate the model? So it is by using recall, by using precision. Okay, so you need to actually tell the interviewer what it means: true positive by true positive plus false negative. Okay. So Agam, like, which thing were you not able to understand? Were you not able to understand both of them? Were every one of you, were you able to understand? Uh, Please tell me. Okay, give summary. Okay. So see, precision is what? Precision is what, as I said, of all the people see, this is what. Okay, let me write precision. True positive plus false positive. This means, in both the cases, what is your model say? Model is saying that there will be default. In both the cases, what the model is saying, it is saying that there will be default. But true positive means actually, in actual, how much default was there, right? True positive means that the model predicted positive, and actually also there was positive. Okay, so this is what precision means. It means of all the people your model said it will default, how many actual default? So example, let's say out of 10 predicted default, let's say your model said there were 10 defaults. Let's say your model said that there were in total 10 defaults, but in actual there was only 8 defaults. So what is your precision? It is your actual defaults, which is 8, by how much your model predicted in total. It is 10. So your precision is what? 80%. Okay, your precision is what? 80%. Okay, is this clear? Please tell me. First, tell me, is this clear? So see, if you see the formula, true positive by true positive plus false positive, just see in the denominator, what is the prediction? It is positive, which means the model is predicting that there will be default. And the numerator is what? How many actual default were there, right? True positive. So this is out of 10 predicted default. If actual is 8 default, this will be your precision. Now accuracy, no, sorry, now recall. So recall is nothing but, if you see, recall is nothing but true positive by true positive plus false negative. Okay, now what does this mean? Of all the people who actually defaulted, what it is saying is, this is actual default, as we know from above, right? This is actual default. Now this denominator means what? Of all the people who actually defaulted, how much the model catch? How many defaults the model catched? So see, true positive means what? Model has predicted positive, but and actual also it is positive. False negative is what? Model has predicted negative, but actually it is what? Positive, right? Actually it is what? Positive. So when we add these two, what are we saying? How many default that the model has been able to catch? Okay, how many default the model has been able to catch? So actual default by how much the model was able to catch. That's it. So let's say if yeah, so this is what it means by recall. See, again, there's no easy way to explain this. As I said, um, I know it's little tricky, but this is how you have to, learn. And the way to learn the formulas is, as I said, um, you know, the way to learn the formulas is simple. True positive by this whole is your precision, and true positive by by this column is your recall. That's it. Now let's understand what is F1 score. Now let's understand what is F1 score. See, F1 score is nothing but it is a balance between precision and recall. Okay, it is a balance between precision and recall. So it is useful when you need to find the trade-off. Okay, so F1 score is nothing but 2 times precision times recall by precision plus recall. So P is what? Precision, and R is what? Recall. Okay. So F1 score is 2 times precision times recall by precision plus recall. So just for example, if let's say, if let's say what happens is for one model, let's say you build two different models, okay? For one model, your precision was high, and for other model, your recall was high. So let's say you have this case. Excuse me. So let's say your precision is high but recall is low for your first model, and for your second model, your precision is low but your recall is high. Then what will you do? Then there comes the savior, which is F1 score. So what you would do is, let's say your precision is 60% and recall is 75%. So how would you calculate your F1 score is 2 times 60% times 75% by 60% plus 75%. So this is nothing but 66.7%. So you will calculate, this is your model 1, let's say, and similarly you will calculate model 2. Let's say precision is 80% and recall is 40%. So you'll calculate F1 score for this, which is 2 times 80% times 40% by zero point 0.8 plus zero point 0.4. So this is nothing but 2 times zero point 0.8 times zero point 0.4 by 1.2, right? So this basically can be cut. This is nothing but 3, and this will be something around, let's say, somewhere around 50% or even less than that actually, because this will be 16 by 30, so let's say 8 by 15, something, so anyway we know that this score is more higher, 50% or something, whatever it is. So we know that model 1 is actually performing good. So this is when you will use F1 score, when you need to find a balance between your precision and recall. If in case, let's say, you build two different models, and there is a situation wherein, for one model your precision was high, and for but your recall is low, but for the other model your precision is low and recall is high. So it basically helps you to trade off. That's it. Okay, is this clear? Please tell me, is this clear? Did you all understand what is accuracy, precision, recall, F1 score? See accuracy, as it's okay. Let me summarize it again. So we have accuracy, precision, F recall. See, accuracy and precision and F1 score, it's very easy, right? If you remember, see, F1 score is 2 times precision times recall by precision plus recall. This is the most easiest formula, right? Accuracy, as I said, it is true positive plus true negative by all. True positive plus true negative plus false positive plus false negative, right? Now, what is this precision? It is true positive by true positive plus false positive. And in recall, what you have to change is just the second part, true positive by true positive plus false negative. So the way I used to remember in my interviews were, because it is P, thereby P will come here. Okay, otherwise, see, this part is all the same. This part is all the same. What is changing is this part, right? What is changing is this part. So always remember, when it's precision, it's false positive. When it's recall, it's false negative. Okay. Okay. And again, see, these two formulas are straightforward. These two formulas are straightforward. People just get confused between these two formulas in general. Okay. And I told you the trick. Always remember, when you have precision, you have false positive. When you have recall, you have false negative. Okay. Is this clear? Please tell me, is this clear? Okay. Now let's understand what is AUC ROC curve. And this is very important. See, AUC ROC curve. And this is very important. So see, okay, first let me write what is ROC. It means receiver operating characteristics. And what is AUC? It is area under the curve. And which curve is it referring to? It is referring to ROC curve, okay? Area under the ROC curve. So what happens is, it is, if you see, it is basically a diagram like this. You basically make a curve on your X and Y axis. So on your X axis, you basically plot false positive rate. Okay. And on your Y axis, you plot true positive rate. Okay. So now the question is, so this is basically, it is a graph. So what is ROC? If you see what is, first let's see what is ROC. So it is a graph that shows how well your model separates default from no default across all the possible thresholds. And I'll give you a practical example to make you all understand. Okay. So it's a graph. It is a graph that shows how well your model predicted, or how well your model separates defaults from no default. How well your model separates default from no default across all the thresholds, all possible thresholds. Now I understand that, just by definition, it's a little hard to comprehend. So what I have done is, let me give you a quick example so that you understand. So basically we have different thresholds here. Okay, we have different thresholds. Can you tell me, for logistic regression, what is the threshold that we keep? Let's say, okay. First, can you tell me what is the threshold that we keep for logistic regression? 0.5. That's right. That's right. 0.5. So what I'll do is, let me write the definition of true positive rate. So true positive rate is what? True positive by true positive false plus false negative. And false positive rate is what? False positive by false positive plus true negative. Now, this is just for you to remember that we need to calculate these two across all different thresholds. Now, let's do this exercise. Okay. Let's say we have our Y actual. Let's say, let me take an example that someone has, okay, let's say 1 0 1 1 0 1. Okay. So and this is our y actual, and let's say we are calculating y hat, which is the model has predicted this 0.8. So this is what has happened in reality, and this is what the model has predicted. Okay, 0.96, 0.4, 0.3, 0.2, 0.7. Okay, now, okay, tell me what is 0 and what is 1. Can you all tell me what is 0 and what is 1? Which is default and which is non-default? Can you tell me? So in this case, in PD model, what is 0 and what is 1? Which one is default and which one is non-default? Just think which one is default. So when I say 0, what does it means? And when I say 1, so 0 means non-default. Always remember 0 means non-default and 1 means default. Okay. So here what I'm saying is that there was a default and the model predicted 80% chances of defaulting. Here there was no default, but the model predicted still a very higher probability of getting defaulted. So as we know, 0.5 is the threshold that we keep, right? So let's start with 0. Let's start with, so what happens when we keep 0.5? Can you all tell me what happens when we keep threshold as 0.5? So anything greater than 0.5 will be 1 and anything less than 0.5 will be what? 0. Correct or not? Tell me, correct or not? Anything greater than 0.5 will be 1 and anything less than 0.5 will be 0. This is what we have studied from logistic regression or the sigmoid function. Do you all remember this? Please tell me, do you all remember this? Right? So now what we have to do is, instead of taking 0.5, let's take 0. Let's take 0. So anything greater than 0 will be what? 1. So here, what is 0.8 is greater than 0? Yes. So everywhere it will be 1. Okay. Now let's calculate our true positive rate and false positive rate. So what is our true positive rate? It is total positive by total positive plus false negative. Okay. So total positive means what? That actual is prediction is positive. Prediction is what? Positive, which means prediction is 1. Let's say prediction is what? Positive, which is default. So prediction is what? 1 and actual is also 1. False negative, which means prediction is negative. Negative means no default. Negative means what? No default, and false means there was a default. So let's see this cases 1 1. So let's see where do we have true positive means what? 1 and 1. This is your actual and this is your prediction. So let's see where do we have 1 1. We have here 1 1, 1 1, 1 1, 1 1. So how much is your true positive? It is 4. Okay. And how much is your false negative? Which means 1 and 0. Okay. False negative is what? 1 and 0. So let's see where do we have 1 and 0. There is no 0 here. So that's why this will become what? 0. So then let's calculate our true positive rate. It is what? True positive by true positive plus false negative, which is 4 by 4 plus 0. This is 4 by 4. This is 1. Let's calculate false, and then now let's calculate what? So we have calculated our true positive rate. Let's calculate false positive rate. So false positive rate is what? False positive by false positive plus true negative, right? True negative. So tell me one thing, what is a false positive and what is true negative? So what is a false positive? Which means prediction is what? Positive, which means default. And in reality, there was no default. Here, true negative means what? Negative is what? There was no default. And in reality also, there was no default. Okay. So positive means what? There was a default, and false means opposite. Negative means there was no default, and true means yes, it is correct. So let's see 0, 1. Let's see how many cases of 0, 1 do we have here. So 0, 1 is this is one case, and 0, 1 this is the second case. So 0, 1 is 2. And how much is 0, 0? There is no 0, 0. There is no 0, 0. So this will be 0. So how much is your false positive rate here? False positive by false positive plus true negative. So this will be 2 by 2, which is 1. So now what we'll do is we'll plot a we'll plot this, right? Which is true positive rate by false positive rate. So 1, 1. This is 1, this is 0, this is 1. So this will be 1 comma 1. So this was when we kept the threshold as 0. When we kept the threshold as 0. So like this, what we'll do is we'll change the threshold now. Instead of 0, we'll do point, let's say point 1, point 2, point 3, and so on. Let's calculate at point 5, which is our normal case. So this will be 1, this will be 1, this will be 0, 0, this will be 0, 0, 1. Okay. Now this is what the model has predicted, and this is what the this is what the reality is. Yeah, okay. Now let's calculate our true positive rate and false positive rate at 0.5 threshold. At 0.5 threshold. So we already know what is true positive rate. It is true positive by true positive plus false negative, which means let's calculate this part again. Okay, let's calculate this part again. Okay, so let's see what is 1. Where do we have 1, 1 in our case? In our case, see 1, 1 here we have, then here we have 1, 1. Okay, which means 1 here, 1 here, 1 here, 1 here, right? So this is 2. And what is false negative? 1, 0. Let's see how many 1 zeros do we have. So this is 1, 0. This is 1, 0. So we have how many 1 zeros? We have 2. So how many 1 zeros? We have 2. So now let's calculate 2 by 2 plus 2, which is 4, which is 0.5. Similarly, false positive rate will also calculate this same thing. For false positive rate, we have these two. So let's calculate false positive rate. Okay. So what we need to look at is 0, 1, false positive 0, 1. So 0 is here and 1 is here. So that is one case. Here it is 0, 0. So for 0, 1, we only have one case. And for 0, 0, let's see 0, 0. So only 0, 0, how many cases we have? 1. Because see here it is 0, 1. Okay, but for 0, 0, we have 0, 0 here. So only one case. So this will be 1 by 1 plus 1, which is 1 by 2, which is 0.5. So 0.5 by 0.5. So this will be like here. So what will happen is, will basically, there will be, will basically at different thresholds, will calculate this value. Okay, at different threshold, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Okay, so at different threshold, we'll calculate the true positive rate and the false positive rate. And let's say we got this figure. Let's say we got this figure. Something like this. We got this figure. So always remember that anything which is so what will draw a straight line from 0, 0, will draw a straight line from 0, 0, passing from 0, 0. So if your model, if this curve is above this line, then it means it is a good model. it means it is a good model. Always remember, the more above it is, it means it is a great model. If let's say, so false positive rate, true positive rate. So we know that this is line, okay, this is our line which is 0.5. This is our line, it means 0.5. So if let's say you got a figure like this means perfect model. Let's say if your line comes like this at different threshold, it means a perfect model. If it comes like this, it means your model is random. And let's say if it's somewhere here, it means worse model. Okay, so always remember, if your AUC is greater than 0.5, it means good model. Okay, if your AUC is 1, it means perfect model. If your AUC is 0.5, it means random model. And if your AUC is less than 0.5, it means bad model. Tell me, is this clear? Is this clear? Please tell me. So what we are doing is, eh, so what we are essentially doing in the ROC is, we are basically it is a graph that shows how your model separates your default from no default across all the possible thresholds. So this is what ROC means, and AUC means your area under the curve. See, what is the area here? This is your area under the curve, right? This is the area under the curve. So we basically say that the more the area under the curve, the better the model is. Okay, the more the area under the curve, the better the model is. Okay, I see one question. What if the AUC ROC is 0.85? That means it's a good model. That means it's a good model. See, as I said, the more the model is closer to this perfect line, the better the model is. That's it. It basically, when I say, it basically distinguishes the defaults and the no defaults. Okay, is this clear? Please tell me. Is this clear? So this is, so as I said, this, so what is your ROC? ROC is receiver. Okay, so what is ROC? ROC is receiver operating characteristics, nothing but, it's basically, it is a graph between the total positive rate and false positive rate at different thresholds. And as I said, this is how you may basically, you'll calculate at different thresholds how much is your true positive rate and your false positive rate, and accordingly you will build this AUC ROC curve. Okay. Okay, is this clear? Please tell me, is this clear? So this was all for today's session. As I said, what we have covered is accuracy, precision, recall, F1 score. Now, just a homework is to read K statistics and population stability index. I'll give you a hint of what is population stability index. See, a lot of times, let's say, you build this model for, let's say, using a data set from 2000, let's say 2020 to 2025. Let's say you build a data set using this, you build a model using this data set, and now you are trying to do the prediction for 2026. Lot of times what actually happens is the behavior of this population actually changes. Okay, a lot of times the population behavior changes, and that's why the model that you have built using this data is not applicable for this particular time for 2026. What has actually happened is that the population behavior has changed. When the population behavior has changed, you cannot use the same model, and that is why it is very important to look at population stability. How stable is your population? So this was all about, how to evaluate your credit risk model, and I hope you enjoyed the session.